while browsing on eBay for something completely different, as often happens, I came across two LED beanies and thought, oh, that's quite interesting. I think I'll buy one of each and try them out. So this one's the luxury version with the USB charging facility, and this one's just got little button cells. So this one, if you push the button once, it goes full brightness. Push it twice, the second time should I say, it goes dimmer, and push it again, it starts flashing two outer red LEDs, and then it goes off. This, on the other hand, is just where you click the switch in the back, and it just lights continually, and it is just a row of 5mm LEDs. And in this case, the construction of this one is very simple. It's one of these little CR2032 lithium cell holders with a switch in it. A couple of wires coming out. This is held in place by an elastic strap. A couple of wires coming out to a connector with they've soldered the leads onto the back of a circuit board connector and put some hot melt glue. And then two wires going onto the back of a circuit board, which is just a thin section of circuit board held in place by this piece of sort of flexible plastic that's been sewn into the hat. And I have to say, this one is rubbish. It produces a very pointed dot of light, and if you were looking here, then that dot of light is somewhere up there. And when I was trying to adjust it, I was thinking, well, maybe it could be tilted down by, sitting it down the battery pack. When I did that, a wire popped off because there's no strain relief, so I had to solder the wire back on. So this is just a pile of crap. It really is useless. So that's that review done. Let's take a look at this one now, because it's much more interesting. And it's got a module here that you can pop out. They've got a sort of rubber grommet that is basically put into the fabric and then sewn round. And here's the module. And it takes the standard micro USB charging connector. So let's see if we can get this open. Spudger. I'm guessing the circuitry isn't going to be that complicated inside. Protection circuit for the chip, maybe? Ooh. Oh, this is a... Am I missing something here? Oh, there is a screw at the back. Maybe that would help. Let's remove that screw. Just at one end. This one puts out the splash of light. And it's not too bad. It's not great for working with, because once again, if you're working in the vicinity, the light will be biased above you again. It's not that handy. I'm guessing ultimately it's certainly not going to replace an LED head torch. Oh, this is getting quite crunchy here. Crunchy. Oh, blimey. Yeah, this isn't easy to open. Oh, there we go, there we go, there we go. So what size is the lithium battery going to be? Right, so that comes off to reveal the circuit board. Circuit board, is there anything really obvious? Oh, it's got a little plastic, it's got a couple of, it's plastic rivets, it's sort of staked in, so let's see if we can break those. Oh, one broken. Snips. I'll just lop that little rivet completely off. Okay, they have jammed in a modest size of lithium cell. Not seeing a protection circuit board on it. Ooh, maybe I should have looked at the front before I said that. So let's see what it's got. It's got the anonymous 8-pin chip, as so many of them do. It's got a DW01 there. And that'll be the MOSFET package below it. So that is the battery protection circuitry there. And then it's got this little... is that a transistor for the LEDs? Oh, that might actually... Oh, one of these. I'm guessing that might be charge control for the... This is quite complex circuitry. I'm just going to take a picture of this and show you a close-up of it. So here's a close-up of the circuit board, and I have to say it's actually quite sophisticated, certainly for a beanie. So the circuit board has protection for the lithium cell. The lithium cell connects here, and I did notice in the back the lithium cell is just nudged, it's just slightly pinched with its position when it gets screwed in on this pillar here. That's not perhaps the nicest feature, but Besides that slight pinch of the lithium cell, which hasn't perforated it, the lithium cell has got the two tabs sorted directly in. Instead of having the protection on the lithium cell itself, it's got the two protection chips on the circuit board. So you get the DW01B and you've got an 8205A MOSFET package, which gives the equivalent protection. It's like the little circuits that are always built onto the phone cells. In this case, it's also got a 4054, which is a programmable current limiting supply for charging lithium cells. So it does have the full lithium cell charging circuitry. The LEDs are controlled by this anonymous 8-pin chip, as they usually are. And aside from just switching on, say it uses this transistor here for switching on the two red LEDs via a 1 ohm resistor, so it'll be pulsing at quite high current. But it switches this one on to switch the 4 parallel white LEDs. But I was looking at the circuitry and thinking, well, what's that resistor there for? Is it just perhaps to take some of the load off the charging circuit, the heat dissipation from that wee chip? And then I thought, oh no, it's tied into the transistors for the LEDs. And I reckon that's a current sensor. I reckon it's actually got current control to ensure consistent intensity of the LEDs. And if that's the case, well, let me doodle a circuit. Let me doodle that. So the LED control looks like this. You got the plus volt rail, which is round about, say, 3 to 4.2 volts, depending on the state of the lithium cell. The LEDs will be connected to the positive rail, all 4 of them. And they will then be connected, all in parallel, down to the transistor that turns them on. And then that resistor, which is 3.3 ohms, 3R3, and then down to the negative rail. Let's call it 0 volts. But there's another transistor. So this transistor here is turned on via a resistor from the control. But there's another transistor connected here. And that connection goes straight to its base, and it pulls directly to ground, and what it does is it shunts this transistor. As soon as the voltage across this resistor here starts going near, I'm guessing, near 0.6 volts, this transistor turns on and it pulls the current it sort of reaches an equilibrium point that the current is regulated. This transistor will go into a sort of it's not fully on, it's not fully off, it will be a sort of midpoint position, and it will act as a sort of active resistor and limit the current. So if that was the case, I would expect to measure, in normal operation, I'd actually measure 3.3 about 0.6 volts across that 3.3 ohm resistor. Let's give that a go. Let's bring the meter in and actually do that then. So where is that little resistor? It's right there, so let's see if I can turn the LEDs on at full power. Turn this to about 2 volts. And we're looking for roughly about 0.6 volts, if I'm right. This is going to be quite tricky because, again, I'm looking straight into lights. Could have got the sunglasses on for this, but didn't. So there's the, let's see if I can not short something out here. 0.6 volts. Okay, I got the leads round the wrong way around. It's 0.6, 0.7, but that's close enough. That is exactly what it's doing. It's acting as a linear current regulator. That's interesting. Now, I notice that when you plug this into charge, it's also senses that when the charging lead is connected for no good reason other than to actually start blinking the two red LEDs at very low intensity just to show that the unit is charging. I don't know what it does at the end of charge, if it keeps them blinking. I haven't charged up fully to test that. But I was hoping that it might act as the emergency light, that when you unplugged it, the lights would light again. But alas, no, it turns straight off. So yeah, that's quite interesting. Let's see, have I covered everything? There's the current regulating circuitry for the white LEDs, there's the transistor that switches the two red LEDs, some support components around the chip that does everything else, and then the battery protection circuitry, and that's fundamentally about it. It does seem to have polarity protection in the input as well. I've just noticed that this very second. Yep, that's got polarity protection on the input for the charging circuitry. That'll also, to a degree, stop it from discharging back into the USB power supply, but it also gives it the polarity protection, which is quite nice. So yeah, it's quite complex really. And this one, because it puts out the diffused light, when you walk into a room, it adds a splash of light. Not ideal for working again, but as a sort of ambient illumination in a room, it's quite neat. So I don't know how long it will last. Certainly, let's work out the current that's going to be likely to be through that. So the current we had was around about 0.7. The voltage we had across that resistor was about 0.7. So we can work out the current flowing through it at the point it reached that level and it started regulating. So the I equals the 0.7 divided by the 3.3 ohms. So the current would be 200 milliamps, roughly 50 milliamps per LED. And that means that, you know, on this little lithium cell, I'm not sure what its capacity is, but that's quite a lot of current. So you're going to get maybe about an hour or so at the full power. But if you run it at the lower setting, you're going to get a lot longer run time. So it's quite neat. The red LEDs are being theoretically pulsed at quite high current just for extra intensity. But they are fairly high power LEDs. So yeah, it's quite an interesting little thing. This is definitely the winner, this one, but still not practical. I think if you were really wanting a good head torch, get an actual head torch as opposed to using one of these things built into the beanie. But it's still novel, and I like the way it goes in as well. The way it sort of pushes into this frame. I'm pushing it in from the wrong side, aren't I? Yes, I am. But yeah, the way it sort of pushes through the sort of grommet in the material like that, it's quite an interesting light. Very interesting because of all the support circuitry and the fact it takes it quite seriously, and you know, they have gone to an effort to make a proper controllable little light with the current regulation and everything. It's quite neat. So yeah, quite interesting stuff.